Well, hello, Year 12 Method students. This is Academy V. Like, subscribe, and share if you find this video useful. Today, we are looking at transformations of e to the x. And most of the time, if you have the same base, transformations are pretty easy. However, today you have a different base, and so we're going to show you the shortcut of how to change from e to 2 or vice versa. So the shortest way of doing this is to use one of the log rules. So here are the log rules in various forms. This one is from qmath.com, and you can take a screenshot of that if you prefer the Word version. And you can also use the rules like so if you prefer rules 1 to 7. So the thing we're going to use is rule number 7 on this list, or the number raised to log rule here. So in our context, this 2 over here, we can write as e to the power of log to the base e of 2. And that x, which is sitting there as a previous power, is still sitting there waiting. And then hopefully you can see that all that is now is you have a power of e up here raised to a power outside the bracket. And so by one of the index laws, for example, something like this, you can then multiply the powers together. And so this would be then e to the power of log to the base e of 2 times x. And then you can see, hopefully, that you now have the same base as before. And you have a transformation that is easy to spot. So when you are looking for transformations, the function notation way of seeing this is different from the variable, or whatever the dash method is called. So I'm going to show you the shortcut, which is to say that we go from y1 back to e to the x as an interim, and then forward to e to the log e of 2 times x. And so what we have to do first is divide the x by 3. To get back to e to the 1x. And then from there, we have to multiply that same x by log e of 2. So our transformations actually look like this. X, y changes to x divided by 3y. Nothing's changed in the y's. And then you've got x over 3 times log to the base e of 2. And the y stays the same. So the transformation that has occurred is, first of all, you have multiplied by 1/3 from the y-axis. So that's a dilation by a factor of 1/3 from the y-axis. And then, let's make that a little bit larger. 16 points probably better. And then the second thing that's happened is you have then multiplied by log to the base e of 2 from that same y-axis. Okay. We started with our green graph, and we ended up with our blue graph. And what we've done is we've rewritten using our transformations, that we've gone from green to blue using this particular transformation here. So you could pause there and be very happy with that result. If, however, you did not know about these log rules, we can go from first principles. So I'm just going to flip back at some old notes. And we can ask the basic question, what value of k makes y1 equal y2, which is 2 to the power of x? Question is, in words, what value of k makes y1 equal y2? And so you can actually start the equation by saying y1 equals y2. So the right-hand side must equal. So we have e to the power of kx equals 2 to the x. And then I am going to choose logs of both sides. And let's say I choose a random log, like log to the base 10. There are other ways of doing this, and it just depends on what you want. So for now, because I don't really know where I'm going, I'm just going to use a different log. So if you have log to the base 10, remember we want to make k the subject. So k is what we want. So we can then separate our k out as a number we can come out the front. So k log to the base 10 of e to the x equals log to the base 10 of 2 to the x. And that applies the log rule where you have log a of m to the power of p equaling p log a to the power of m. And even if you have some kind of other constant power up here, then you can still leave that power in there. So if we look at our various log rule versions, this will be rule number 3 on the Chill Math website, and it will be the power rule according to the qmath.com. Okay, so let's have a look at the notes again. And so now you can make k the subject, so k equals everything that was on the right-hand side, copy and paste, divided by the log to the base 10 of e to the x, copy and paste again. I haven't applied one other log rule that I need to. And I could have done it earlier, but I just thought I'd keep it simple. So again, I'm applying this rule here, which on this rule, it is the power rule again. And on this list, it is rule number 3. So I can then bring my x's down. So this x comes to the front of the numerator, and this x comes to the front of the denominator. And again, I could do the cut and paste thing, but I don't really need to. Log to the base 10 of 2, and then x log to the base 10 of e. And then our x's will cancel out very nicely because x divided by x is 1. And then in the last step, we can actually write this fraction here as a single logarithm, which is log to the base e of 2. And that is using the change of base rule, which is this one here in QMath, or not listed on this one. Interesting. Okay, it is what it is. And so the change of base rule looks like this: log to the base of some other random base, could be t, for example, of a over of a is the same as log to the base a of another base. I don't know what I'm saying. Sorry, try that again. If you have two numbers, a and b, and they're both logged to the same base, then you can rewrite them as log to the base of the bottom denominator of what's in the numerator. That's how I remember it, just by location. So we don't really need that scriptural thing. Okay, so how is that helpful? Some questions will step you through this process of finding k. And so to answer the question, what value of k makes y1 equal y2, you now have the answer. K is log to the base e of 2. There. And you can again disappear and answer your question and be happy with that. Now, those of you who are actually a bit more experienced and maybe have a bit more hindsight, you can actually take log of both sides and be strategic much earlier. So from here, what you could have done is taken logs of both sides with either base e or base 2. So knowing that I want to go from base e to base 2, the best way of going about this is I want to get rid of 2, so I would take logs to the base e of both sides. So if I take logs to the base e of both sides, it just means that you're going to get there a little bit quicker. So once again, we can bring the k down the front. That's a very big highlighter. Let's try that again. K out the front. So we have k log to the base e of e to the x equals log to the base e of 2 to the x. I can leave my k on the left-hand side, which means I must divide by log to the base e of e to the x. And I'll just copy this out again. Good. Yeah. And then from here, it looks very, very similar. You could even go a further step faster and recognize that when you have the same base here, so for example, log to the base a of a, that equals 1. And so log to the base a of a to the power of some letter equals b times 1, because b comes down to the front using the power rule. So you could have had x down the bottom here and x log e of 2 up here as well. Your x's will cancel, and that gives you log to the base e of 2. In case you wanted the in-between step, which I suspect some of you might, if you're listening at this point, let's get rid of that and make it over here. The in-between step was to bring the x's down for both of these. I'm going to get rid of these x's and write them down at the front. And then recognize that log to the base e of itself has to equal 1. So that was the in-between step right there. I'll just write it out over here. Log to the base anything of the same thing equals 1. And that, according to log rules, is number 5 on this list. And log of the same number as base on this list. All right, so I hope this helps, and I wish you all the best and happy studying. Thank you very much. Like, subscribe, and share. Have a good day.